Hello, good evening. Can you hear me? Hello.
Yes, sir. I can hear you.
Yeah,
Good evening.
yeah. How are you?
I'm good, sir. I'm very sorry I was late on the traffic.
Okay, no problem. We'll start. Okay. Okay, so basically
Yes.
today I discuss about the mainly future prediction of land use land cover and also discuss about the InSAR data, how we can work with the InSAR in the Snap remote sensing technique. Okay. So first of all, I discuss about the future prediction. Okay, then you also try to develop your own code using your own data. Okay, further face any problem, they also guide you how we can easily work with the future prediction. So, okay, let me share my screen and then we can talk about the InSAR, okay, for the Synapse software. So further you can simply share your own screen, then I will guide you. Okay, so let's go, we'll start first. Let me share my screen.
Okay, sir. You are recording the class.
Yes, no problem.
Okay.
Can you see my screen, yeah?
Yes, it is coming.
So for the future prediction of land use land cover, when you work, so we are just use different types of method, or you can also use different types of ready-made plugin. Okay, so this plugin sometime we use here the QGIS Molas plugin. Sometimes we also use the Tarset software. Okay, sometimes we also use the Erdas Silva. Okay, so if you simply search suppose some paper from the Google Scholar, so there use the different tool or different plugin. Suppose I simply search here LULC future prediction. So if you check the some paper, this is the one kinds of dynamics of future prediction of land use land cover in the basin of this river, machine learning that uses the machine learning technique. So now if you check the algorithm, so what types of machine learning they're using here, then we can get the idea. So in this time they are predict land use land cover for 2030, 40 and 50. And if you check they are used at the support vector machine. Okay, and they are used at the Google Earth engine. You can also use the Tarset software. Okay, so basically this is the Tarset software they are using here. Tarset is one kind of geospatial tool. It's help you to identify different types of environmental monitoring model we find out. So in this time from the Tarset they are used at the CAMC Markov model, and then they are make the land use land cover classification, and they are used at the three land use land cover basically for the three time. Okay, for the 2030, 40 and 50. Okay, so this is the one kind of model Tarset. We find out the one way, it's called the Tarset. If you check the another way, so this is another paper. So in this paper land use land cover change prediction, mainly urban development they are used here, and future perspective. So in this paper they are used at the, okay, let me check the methodology section. So they are used at the land use land cover, so multiple performance metrics LULC, and for modeling for future they are used at the CA model. Okay, CA Markov model. Okay, model utilize the transition, then neighborhood effect, and also use at this type of LULC. But which technique they are using here? So for modeling, okay, let me check. There is the hybrid model, and also use the time series modeling for land use land cover changes. Okay, for the different time, and they are used at the CNN, mainly convolution neural network, using deep learning. Okay, and also use the artificial neural network for prediction. Okay, so in this time it's only used for LCM. Okay, so you can see that also used at the Tarset. Okay, Tarset land change modeler. So Tarset software we find out a modeler, it's called the LCM, land change modeler. So this modeler we can easily use, and you can see we can also access the Tarset land change modeler from this link. Okay, you can easily get the Tarset land change modeler, so you can also download, and Tarset is supported by Windows. We can easily work with Python or C++ or high level language such as Delphi or C++. It also supported. So maximum paper For future prediction, they are used at the different types of tool or model. Okay, mainly they are used at the different types of software, such as some paper use the maximum paper use the TART set. Okay, so TART set is very popular for applying the artificial neural network or CMR model. So it's very important for the TART set we also use. As well as if you want, we can also use the another method. It's called the machine learning model. So in the machine learning model, we can also use the Google Earth engine. So we can easily apply the Google Earth engine, and further we simply apply machine learning. Okay. So today I discuss about that how we can easily apply the Google Earth engine, and then how we can easily work with future prediction of land use land cover classification. Okay. So then you try to apply your own data, then we just work and then check the result. Okay. So when you work with land use land cover, we need the some data. So basically we need the some dependent and independent variable. Okay, dependent and independent. Dependent basically it's depend on your land use land cover classification map. Okay, suppose if you check the one result, so if I show you, so in this case here I use this type of variable. If you check, so first time this is the prediction result, and here we use the land use land cover, suppose 2014 and 2024. Okay, to land use land cover, distance to river, then land use land cover for different time period. Maybe we just use the 2 time period. So this is the first factor. It's called the distance to road map. So just we simply apply the Euclidean distance, Euclidean distance, and make this type of map. It's called the distance to.
Sorry.
Yeah, please.
Can you remove this small pop-up window?
Okay.
Yeah, yes.
So we are just simply create the distance to road map, and then simply import in Google Earth engine as a GeoTIFF file format. Then we can get this type of map. So it's the distance to road map. It's one kind of factor of for land use land cover future changes. So just I simply import this factor, land distance to river. Then elevation or DEM is an important factor for future change of land use land cover. So this is the DEM data. So here we find out that where is the high elevation, where is the low elevation. We can get this type of idea. And then slope is the another factor for land use land cover changes in the future. Then aspect, many flow of direction. Then land use land cover, this is the 2014 24, and this is the 14. Okay, this is the 14. So we find out this type of changes of land use land cover between the 10 years, and this is the distance to river. So we find out some river and calculate the distance to river map or distance to water body map. Can also use the population density, mainly where is the high population, where is the low population. So this is the population density map. And further we simply compute the change between the 10 years, suppose 2014 to 2024, 2014 to 2024, we compute the land use land cover change map, okay, between these 2 time period. And further this change we try to predict after 10 years what happened, after 10 years what happened. So just we apply the machine learning, and then we just apply the regression model, and then compute the land use land cover prediction in 2034. And now here we find out that if you check between the 10 years, we are just working 10 years, and so further when I predict our interval is the 10, so then I simply predict that 2034. Suppose now you need the after 10 years, so after 2034, after 10 years 2044. So then you can simply use the 2014 and 2030, suppose 2024 and 2034. Okay, just use this 2 map as a reference map, and further we can predict in 2044. Okay, suppose you need the after 10 years, mainly 2054. So for that simply use this another before 2 period land use land cover map, what before 2 decades land use land cover map we can predict. Okay, this is the way for prediction for land use land cover. So now I will try to explain about that, the code, then you can get the more better idea. So first of all, here I simply imported all of my necessary file. You can see land use land cover 2014, land use land cover 2024. Okay, simply import it as a GeoTIFF file. Simply import in your asset tab. And then we simply import the your NASA SRTM DEM data, 30-meter DEM data, and also import the population density. But it also better if you have your own population data set, mainly census data set, so then it will be more better, we can get the more accurate result. But it's a world population projection data, it's available only from 2021. Okay, but if you need the more update data, then you try to use the more update census data, and then make the population density map, help of IDW interpolation, and make the population density map. Okay, and this map we can simply use in Google Earth Engine. Okay, so in this case I just use this data, but when you work with the real project, try to use the more update census data and make the population density map. And this population density map simply import in Google Earth Engine as a GeoTIFF file format, and also work with that. And now we also work with, you can see this is the roads basically distance to road map. Okay, we simply use, and this is the road shape file, I think. So this shape file we simply convert as a distance to road map. So you can also import your own road shape file, okay, or also river shape file. Simply upload in Google Earth Engine asset tab as a shape file. It's a shape file, roads or river, and further we simply use it and make the distance to river map or distance to road map. We simply compute. Okay, so now this is our parameter, or this is our independent factor. We are just simply work with this type of factor which influence the land use, land cover changes. So now we simply create the distance to road map. So just I simply call the roads, because this variable stored the your all of road shape file. So I simply call the roads and apply the distance, and search radius I put the 5000, okay, meter, and maximum error just put the 1, and click with your study area, mainly your shape file. Then we can just create the distance to road maps. So just use the distance function and mention the search radius, then we can easily get the distance to road map. Okay, so this is the way to create the distance to road map. So first of all, just import the shape file of your boundary, then we simply call the DEM data, digital elevation model, and clip with my study area, and then display the DEM. Then slope we compute, then aspect we compute, then we just simply display the land use, land cover 2024 and land use, land cover 2014, simply import. And then we just create the distance to river map. So for that I simply call the hydrosheds data. It's globally available, hydrosheds data, and from this hydrosheds data we can get the greater than 1000 hydrosheds value, it indicating about the rivers, mainly rivers. We just take the river threshold value, it will be more than 1000, and then we simply compute the, take the river line or river shape file from the hydrosheds. So from that simply compute the river network and also compute the distance to river. But if you have the suppose shape file of your river, suppose you have the river shape file, so this river shape file you can also use and then apply the same process to make the distance to river map. Just apply the same process. If you have the shape file of your river, then we can easily use the same process. But in this case I just use the hydrosheds data, okay, hydrosheds data, and compute the drainage area, and also import the drainage area. Okay, and in the drainage area I take the greater than 1000, which is indicating about the river, and further we simply just update marks with the river data and click with our study area. Okay, then we simply call the population data set. So this is the population. So basically we select a band, in the population we find out a band B1. So this band we simply import in here and work with that. If you check the band B1, so this is the population density map for this study area. So simply import the population and select the band B1. And also then region of interest, land use, land cover 2014 geometry, and this is my value 0, 1, 2, 3. So basically 0 is indicating about that water, 1 is cropland, 2 is barren land, 3 is build up. And further I just simply define the color plated and also mention the name. Okay, one water, cropland, barren land, and build up. And if you check the name, suppose just click on here, so here we find out the total 3 bands, if you check the band information, 0 to 3, okay, 0, then 1, then 2, then 3, okay, we find out the total 4 class, okay. So when you make the land use land cover, try to put this type of band, suppose 0, 1, 2, 3, it will be more better. So simply put the 0, 1, 2, 3 of your land use land cover different types of classes. Then we simply create the, so now we simply create the land use land cover list, year 2014, and this is it's come from land use land cover image 2014. Then year 2024, it's came from land use land cover 2024, and we simply choose suppose build up area, so it just display the build up area equal to 3, and then we simply compute the area in hectare, so it's not part of the prediction, just simply calculate the area. And also land use land cover 2014, we simply compute the area, okay. So now show the land use land cover change map, just use it, but our prediction will be start from here, so you can see. So we can simply apply the change map, okay, simply create the change map between the land use land cover. So for the create the land cover change map between the two map, suppose I have the land use land cover 2014 and another map 2024, so just I simply create the change map between the two land use land cover. So this is the code, we simply make the land use land cover change two map, and we display the change map, okay, change map land cover change map. So this is our land cover change map, so it's not showing the color, but when you download you can also get the land use land cover change map. So now based on the change map, suppose between the 10 years how it change depend on this, then we simply predict land use land cover 2034. So for that we simply create the image with variable prediction variable. So in this case we create a variables, and in this variable we simply store it all of factor for land use land cover 2014, it's our start, and land use land cover 2024, it's our end. Then we compute the transition, basically change map. So we already compute the change map, so this is the change map, so it's our transition, okay, between 2014 to 2024. Then dem, it's our factor, then slope, then distance to river, distance to road, then aspect, okay. And these things I simply multiply with land use land cover not equal land use land cover 2024, and rename is a year, okay. So this is the 2014 because it's my start time, so always keep the start date in here. In this case our start is the 2014, so just put the 2014 and multiply with land use land cover 2014 not equal, suppose it's not equal land use land cover 2024, and rename it as a year. So now we simply create a list all of prediction variable. So this is the list of our prediction variable, you can see. If you want you can also add the different types of variable, okay, not only for that. In this time we consider start, then transition, then elevation, then slope, then distance to river, distance to road, aspect map, ER, so you can also add, and property name to predict in the end, okay. So now we simply take the some sample, okay, from using all of variable. So all of variable extract 3000 training sample from the transition band, it extract 3000 band, and we simply spill the train data set into 80% data for train our model and 20% data for test our model, okay. Mainly train is spilled two-way, and further we simply apply the model, okay. So in this case we simply apply the random forest regress model, okay, and then train with the train and predict, and also property name, okay. Predict name basically it's just come from our prediction all of variable, okay. Predict name is the mainly end of the year, and property name basically they stored all of property, all of band pixel value or property, okay. And then we simply check the accuracy of our prediction, okay. Accuracy of our prediction, if you check, so this random forest it's classified for the 99% prediction level using the help of random forest, okay. So we find out this type of prediction accuracy or prediction performance for this model. And further we simply predict hour. In this time our predict hour is 2034, okay. So this is the 2034, So just simply keep all of those. So we just land use land cover, so rename, it says start. So these are all of variable or prediction variable, and we simply set the prediction year. So in this case you can see first time I put here that your start year in the variable section, and second time I put here the prediction year. Okay, and define the multiply land use land cover not equal to land use land cover 2024. Okay, and simply connecting with our model. Okay, and then we set land use land cover dictionary. So then further we simply compute the land use land cover 2034. If you check this map, we find out this type of map. Okay, so here we find out that it increased the sum build up area, okay, for region. And also if you just compare this map with the land use land cover 2024, so we find out this type of changes. Okay, and it also show that some water body is also increased. So now you try to adapt this type of code for your own study area, then check what happened, because your data is already ready. So you try to import your all of data, okay, and then try to adapt this code for your own study area. Okay, then we try to check the accuracy and also check the map, what types of find. Yeah, please.
Can we start try to import those data, because you have those data?
So you can also import
now, or...
you can also import later, because we have also another topic also, no problem, we just talk about that.
Okay.
So you try, I will send you this code, you try your own data, and further face any problem, then inform me, I will guide you, no problem. Okay, so now we talk about yeah, please.
Can you also start try to show me maybe by using maybe a TerraSet, maybe?
Okay, model is not in this time. I have not TerraSet software, but I have used the Mollusk plugin. So I have that recorded class about that. I will send you, no problem. Okay. So I will send you the Mollusk plugin, because I am not using the TerraSet in my laptop in now. So I have the Mollusk plugin tutorial. I will try to send you that recorded class. So now we talk about the Snap. So you can simply share your screen and show me that. Then I will try to discuss about that, please. And this code I will send you. You try to adapt. Yeah, please.
Okay.
And I hope you already download the imagery. Yeah, image is very high.
Yes, I have image.
Okay. Just open the Snap and I will try to show you that. Okay, I can see your screen. Yeah.
Do you see my screen?
Yeah, I can see.
You see the Snap?
Yeah, I can see. Yeah, I can see. So this is a Snap software. You can, okay, it's no problem. Just finish. Okay, and here is your data. Yeah, just import the data. Maybe 2 time satellite imagery for the same location.
Yes.
Yeah. Okay, just open, because we can also zip file is also supported. Okay, so
yes.
Okay, no problem. So now this is yeah. Just click on the
image from
2023 to 2nd December.
Yes, and 14 December 2023. I think this is an image.
Yeah, this is the image area we find out in here. Yeah. So now for the image processing, we need to apply different technique. In here you can see it show the radar. In the radar we find out that apply orbit file, radiometric, speckle filtering, okay, and co-registration, interferometric, and then paleometric, geometric. So actually where use it for the different purpose. Okay, so in this case, InSAR is helpful, lot of work. Suppose you can easily identify the subsidence displacement or earthquake displacement or landslide displacement, and in Synapse is also helpful to identify different types of mineral. So Synapse is basically help you to work with only for the Sentinel collection, mainly Sentinel-1 and Sentinel-1 or SAR data or other data is very helpful to work. So I'll try to show you that how we can easily make the pre-process our data. Okay, suppose in this time we simply apply the 2 decades data. Now I want to work with the suppose pre-process, and then we try to extract some information from this data.
Yes, and sir,
Yeah, please.
this image that I've downloaded is the Sentinel-1 image has 2 parts. There is SLOC and the GRD.
Yeah.
These ones I've downloaded are SRC.
Okay, no
Am I
problem.
right?
SLC it's also work for Synapse easily, no problem. And GRD is also okay for the another purpose. We try to work the SLC, same process, no problem. So now I can simply open the one image. You can see the suppose you can see the one image. Yeah, just click on here. So here we find out the bands. Click on the bands. So here you can see different types of bands. So it IW. Just click on here. Yeah, click. So here you can see okay. So then I take the IW2. So basically it show the band about the amplitude V and VS. This type of band is available or not? Yeah, available for that.
This one.
Amplitude. Click on the IW3. Yeah. It show the intensity IW3 VS, then IW3 VB. Okay. And for second image, same, yeah. Okay, just open the intensity band. Okay, just open anyone, yeah. Just double click. Then it will be open.
I think the CLC side the loop complex, they don't have amplitude.
Yeah.
Maybe GRD they have an amplitude.
Yes. Okay, it also have the another window. It display the image or map.
Okay.
So it opening. Yes, this one, yeah.
Yes, this one.
Yes.
This is my image.
Yes, so this image is not pre-processed yet, so that's why you cannot get the more better idea. So okay, so can you find out that your main shape file in your image?
My what?
Mainly a manifest file. If you check the, is there any file? It's called the mix. Click on the metadata and check metadata. I think it's available in the metadata. Yeah. Abstract metadata, original product, or you can just open it from your your computer. Okay, just open it from the computer. Just unzip this file, then you can easily get the more better idea.
Okay.
Yeah. Otherwise, it's not showing the some file or data is not showing in here.
Do you see my?
Yeah, I can see.
My computer.
I can see. Yeah, just unzip. I think it not work because already you've opened this file. So simply close this snap and then reopen again.
Okay.
Then it will be working.
Done, unzipped.
Yeah. Yeah, this file.
But
I
not
will,
from-
it's called the manifest save. You can see that. So this is the main save. It's called the save file. This save file, it's mainly stored all of information of image. So you can simply just drag and open the file in the snap. Okay, also open the snap
This
file.
one?
Yeah, this one. Yeah, save file. It's called the save file.
So should I open the whole image, is it?
Yeah, both of image. Just simply import the save file information in your snap. Okay, is there any open this file or what is the problem? Okay, now it's okay.
It is open.
These two main shape file, first of all, simply open on Snap, and then further we just use work this file. Okay, and then you can get all of information from this file.
Okay.
Okay, so now simply open this two save file on your Snap tab.
Yes.
Why you delete?
Because I think that one image was not extracted all of the file. It has only 2 files, but this one has many files.
Oh,
Have you understood?
yeah. So two
Yes.
image we just work for that because we just identify for suppose displacement or landslide or any occurred. Or,
Mudslide.
yeah.
Even mudslide is possible.
Yes.
And you have said the mineral. You can also detect the mineral using InSAR.
Yes, it also possible. Though for that we just apply the another method. So this thing we also discuss about that your mineral exploration training session. Snap
Yes,
or
I will
also
start as
yeah, also NV is very helpful to identify for mineral NV.
NV software.
Yes. It also helpful for also mineral exploration.
Is it open source? Or
Open source, yeah. Open source, I think, but we can also use the crack version, no problem.
okay.
You don't-
I will start soon. That is a mineral exploration class.
Okay, inshallah, we'll start, no problem. So now mineral exploration using remote sensing, it's very trending. Okay.
Very trendy.
Yes. So a lot of people is more interested to join this type of training
Yeah.
session.
Yes, I see. Yes. Menacing.
Okay, now simply open this two save file on your Snap. So in this time, product explorer, yeah. So product explorer, simply just basically this is a product explorer. It's one kind of tab. It manages all of your file which you upload on the Snap. Okay. product explorer. If you check, just simply drag and open.
What one?
You can see the product
What
explorer.
Okay, this one.
Yeah, just simply drag and open on the product explorer. Mainly your.
So I should drag the manifest.
Yeah.
Say
Yes.
this one.
Yes, this one. Okay.
And another one.
And another one, yeah. Yes. So when you work with SSLC, this product, always keep the same way. Just simply import the save file on product explorer. So now you can see it automatically show you the two path we find out that all of orbit. So after doing this thing, just click on the radar. You can see the radar option.
Basically, we don't inspect the bench.
Not need. We just try. Just first of all, try to click on the radar.
Yes.
From the radar, we find out that one option. It's called the interferometric. And you can see the InSAR stack overview. Last option, InSAR stack overview. No. In the section of interferometric, InSAR, because we just apply for the InSAR technique. So this is the way. From the radar, we simply open the InSAR stack overview. Just click.
Yes.
So now here you can see it open this type of window, and now click on the add opened. You can see the add opened. Click. Okay, so now you can just simply increase the increase your frame for just increase. Yeah. So now here we can get some information. If you check the track information must be same. Okay, always just click on the overview. Click. Yeah.
Yes.
Okay. So now here we can get some important information. First information is the track number is 130. Okay, this track is always similar, okay, for the both of image, because it means that I just use the same location. My tracking is the same location. Acquisition is a different time period. First image we can get the 2 December 2023. Second image 14 December 2023. So this information you can get from this way. Okay, just we can get this. Also you can see the model or height or delta. So it's defined different information. Or orbit, you can see this is the orbit information. Or also get that model coherence, modeled coherence information. We can get this type of information from here. Yeah, this one, modeled coherence. Yeah.
Yes.
So now we work with okay, just click on the radar again. So this is the information. We simply check all of information for our image. So just close it. And now click on the radar again. And here we find out the one option. It's called the co-registration. And click on the S1 TOPS co-registration. Yeah, this one. And from here, just open the tab. Your mainly S1 TOPS. Yeah, this one. Yeah. So now open. It's loading. So it's very important. So it's called basically S1 TOPS co-registration. So here you can see it show the your product, and this product we can easily convert different format. You can see that we can select the data format. We also find out that your product name. So you can click on here. It show the first image. You can say read 1, read 2. Read 1, read 2 mainly we find out that 2 images. Suppose you import the 3 images, then it show the read 1, read 2 and read 3. So now it's only work for the 2 images or 2 SAR images. In read 1 and read 2 we find out this type of information. And also you can read 2 storage the another image. You can simply click on the read 2, then check. Or you can simply also choose, suppose first image you can simply choose read 1, just click on the read and select the first date image, and read 2 select the second image. Okay.
Yes.
Okay, so after that simply check the, you can see the top SAR is filled. Yeah, it's very important, top SAR is filled. So here we find out the different types of band. Basically is your IW1, then VS polarization, VB and VS, okay, and band 1 to 9 maximum we find out this type of information. So now it's mainly it just create the different section, different small section on your grid. Okay, you can see it create this type of things, this type of small section, or small plot we find out in here.
Okay.
So it just extract the more information from this type of small plot from your imagery or section. So we can see if you check, just simply check it show the result for IW1. Okay, then simply select the IW2, then check what happened. Yeah, click IW2. So you can see this is the IW2 information. Then select the IW3.
Yes.
It should cover the another. So now for the different purpose, suppose this is the right section or middle section or right section, then we simply choose suppose IW1, IW3, IW4. You can simply choose this type of, it's mainly your orbit or your location of your imagery. We simply choose using this way. And okay, then you can simply select suppose IW1. Suppose I keep the IW1 and VS and VB.
Yes.
Then check the top search is fill 2. Click on here. Just keep the same. Top search, this one. So this is IW1. We simply choose, or you can choose suppose IW3.
This one.
Yeah. Or you can also decrease or increase also from here. You can, it show the maximum 9. So it create the total 9 plot. Okay, if you need suppose only for the few plot, so simply decrease the number. Okay, suppose 1 to 5. Yeah, this just you can see now it just decrease.
Okay. If you want to work with a small study area.
Yeah. This is the one.
Now it means this one scene has also have the sub scene.
Yes.
Inside one scene, the 3 sub scene, which are IW1 means one sub scene, IW2 means it's a second sub scene, is it?
Yes.
Yeah.
And then click on the apply orbit file and check on the don't fail in new orbit file is not found. Yeah, just click on here. Then click on the file orbit file 2. Yes, same. And then back geocoding. Basically create the SRTM. So basically we also know about that. We can also apply the InSAR data and generate the DEM information. Okay, DEM information. So marks out areas with no elevation. Just check it. No problem. It already checked. And the SRTM.
This back geocoding to create as SRTM from this central image.
Yes. It creates the digital elevation model. And you can also check the bilinear interpolation. Okay, we select the bilinear interpolation and then work with that.
So it is possible to produce the high resolution digital elevation model from this
way. This way we create that high resolution DEM for the real time.
Okay.
And then you can select the right. We can select the right. So now you can simply put the file name. Okay, or you can put any name as a file or directory. You can see the directory. Keep the same name, no problem. Directory, it will be saved in your folder. Kateshi folder, it will be saved. Take this folder. So now click on the run. Just run. Yeah. So now it compute the raster data. So according to your choice, we should choose the IW1, then your subplot, you simply plot, and then top SAR is filled, this type of information. So now it creates.
So it is stacking these 2 images together.
Yes.
And form a single image from 2 images.
2 images. And after completing, it will be added the new image on your product explorer section. We find out the another image automatically add.
Okay. So you're also recording this, is it?
Yes, no problem. So now it shows the processing time. Okay. So now just back it. And new image also added. You can see third number tile. So this is our orbit stack image. Okay. So just we simply make the stack and get this type of image in here. So now click on here the option. Okay. Just click.
Where?
Yeah. Just click in here. Yeah. Just open the image. Just click. Yeah. And you can see the bands.
Yes.
And from the bands IW1, just open. And you can see the intensity IW1 VV, mainly last one.
This one.
Intensity.
Yes, this one
because
is
these are two images. Suppose I want to work with first your this 14 December, then we work with 2nd December. Okay, just open this image, double click or open. Yeah.
This one.
Anyway, any image you can open, no problem. Okay, so we find out this is the image. So this is the image we find out in 2nd December 2023. So now again click on the radar and go to the informametric.
Yes.
Radar, and you can see the and click on the product. From product you can get the interferogram formation.
Okay.
In this section, simply select the last stack image. Simply select the stack image. Yeah, this is a stack image.
Yes.
And then you can also, it also okay name, and also this you can also your directory is also okay. Put the same. Okay, then click on the processing parameter, and here we find out the flat art phase. So subtract the flat art phase, we can get this type of number. It's not need to change. I think it also okay. Subtract and detect the flat art polynomial. It also okay. So now run code. Run the code. Run. Click on the run.
Yes.
Your screen is freezing. So kindly stop the share. Yeah. So okay. It's okay. Run now. Running. Yeah.
It's okay.
Yeah. Working. Yeah.
You see clearly, or there is a problem?
Yeah, it's okay. So now after that, it also added the another new image after this process. So further, simply open the bands also from here.
Yes.
Okay, it also done. It show that processing time also. So now just open the band. So phase, yeah, just open the phase band. You can see the phase IFG IW1. Yeah, this one. Just double click. Double click. Yes. So now we find out this type of information. Basically red color indicating about that more changes. We find out this type of place. It can be changed, different types of changes. Suppose a very high intensity of change in indicating about this type of red color.
In the red color.
Yeah.
Okay.
Okay, so now we also get the another information from here. It also possible you can also create, just a minute. So now click on the radar again. Radar. From the radar, go to the interferometric. And unwarping. You can see the unwarping tab. Yeah, and open the your export. You can see the export option. Snaphu export. Yeah, this one. Export. And the export section.
Sir,
Yeah, please.
in that image that has the red color, I see just some lines. If you are careful, let me show you a little bit. Sorry.
Yeah.
You see this some of like this line like a bouncing.
Yeah.
This one.
Okay, I think we
Can
can
you
also
try to remove this?
you can also try IW3 or IW basically another orbit. Then I hope it will be not happen. So when you try to work with. So in this time we work with IW1. Okay.
This one.
IW1.
I think there is a way.
Yeah.
I think there is a way of removing this.
Yes. So you can also try to work with IW2 or IW3. Then it will be okay. No problem. Suppose in this case I get some dotted line or others. Then I try to use the another orbit or informametric another path. Then I hope it will be okay. No problem. So in this time we work with the IW1. I think IW2 or IW3 is the more better. So now just open the radar, informametric, then unwarping unwarping, export. Okay, now simply choose the last one which we create. Yeah. And format, it's any format, no problem. And then also click on the this one.
I select a folder.
So target folder, yeah. Just simply put your target folder where you save it. So put the same folder where you work.
Okay. I want to create new folder within this.
And put the pull the file name also, no problem. Okay, great.
Okay, maybe unwrapping.
Unwrapping, yeah. And in this folder, you just
Done, sir.
yeah. Then D4 and MC is the initial method, statistical cost model. This is it's same, no problem. You don't need to change. And then click the run. It's okay. Click to the run.
Done.
Yes. So now open this file from your local computer.
Okay. This one.
And now from here you can get that one file. You can see the config file. Just open it, yeah, in your notebook. Just click and open the notebook, or yeah, just notepad, yeah, no problem.
Done.
Yeah, so now from here you can get some information. So if you check, it show the command call. This is the one kind of information. Okay, you can see the command call, this information. We also get it, because it also possible you can also use the command call also. So you can simply search on the Google Snaphu step or Snaphu download. Just simply open a new browser. Just open a browser. Snaph. Just simply open, yeah. Suppose Snaph SU download.
Oh, I have downloaded this. I have this.
Okay, then open it.
Snaphu software, Snaphu.
So this is another.
This one.
It's mainly your yeah. So simply just go to the browser and simply check the and download the zip file. Yeah, this one, yeah, or 64-bit download.
Done.
Okay, now simply unzip this file.
This one.
So now all of previous file simply copy. Basically after unwrapping, just copy all of file. Basically from the unwrapping.
After unwrapping.
Yeah. So he's stored all of those. So
this one.
Yeah, just copy and then open in the new file. Where you just
this one.
In the Snaphu, just yeah.
Paste.
Yeah. In the bin folder. Okay, it's a bin, yeah. Okay.
Yes. Done.
Yes. So basically it's come from your unwrapping. After unwrapping all of files, simply after installing the Snaphu, then simply open the bin and simply paste all of files. Okay, so it's done. So now simply copy the file. So you can simply copy the file path. Yeah. And then open this one. Just copy the file path. Yeah. Just click or copy address.
Copy address.
Yeah.
Yes.
Or if you want, simply write here CMD. Okay, simply write the CMD. Yes, just write here CMD. Yeah. CMD.
Yes.
And then enter. Yes, so you can see directly this file is open. Okay, this folder location, when you just click on the CMD on your folder, directly it's open your interpreter or CMD. It just open. And also it show the directory. So now in this directory, you just simply copy the command. Okay, so which command you can get in the notepad. So you can open the notepad and copy. Yeah, you can see this is the command. Snaphu.
This one.
Snaphu app. You can see that. Yeah, this just copy full.
Yes.
And
paste
then
here.
And paste. Yeah. After the just paste here the bin, and then enter. So now you can get some information. Basically, Snaphu version, and it also showed some unwrapping. You can see also loading this type of information. It's also loading. So after that, we simply open our directory, basically where stored all of image. Okay, let's stack image, and from it just simply open the last stack configuration image. We try to open in the snap.
After this one,
Yeah, it also processing.
yes. So we should wait for the processing to complete, is it?
Yes.